I have decided to use probability to collect some information. And we are going to look at some things. And we're going to analyze it, hopefully unbiasedly, that's my goal at least. And we're going to look at the dangers of COVID. And I've collected data from pretty reputable sites. One of the sites I got my data from was from the government census, and I used that to get the population of America and the population of each of our states. And then I went to another site. I don't think it's a government-run site, but it was run, I think it's Microsoft that ran it. It seemed to be Microsoft. And on this, it gave me the up-to-date information on the total number of confirmed COVID cases and the total number of deaths through COVID. And so what we're going to figure out is how dangerous COVID is, how likely you are to catch it, how likely you are to die. And we'll break it down in different ways. So basically the probability of something happening, right? The top number is how many ways did it happen, right? And the bottom is how many could it happen. So let's do United States of America, which the most up-to-date information I've got, and I rounded off a little bit, but only to make the number crunching a little bit easier. You know, there's no point in calling it 329,751,211, right? I mean, it's minuscule in the big scheme of things. So the latest data that I have from the site that I got to was that 32 million Americans have been confirmed to have COVID. So first one we're going to calculate is what's the probability that you're going to catch COVID? And the answer is 32 million out of 330. So it kind of makes numbers easier if everything is in millions. So 32 divided by 330. Let's try that again. 32 divided by 330. And the answer is 0.097, which I'm going to convert into percentages. So as of, who knows, it was pretty accurate, the up-to-date data. So it's like as of last month, about 9.7% of Americans have caught COVID that have been confirmed. Now, what you can't, what we don't really know yet, and maybe we won't know for years until someone has actually, you know, spent money and looked in it, is that a large, well, we don't know how large it is. It could be 2 people, it could be 2 million people, but there is an unknown number of people who are unconfirmed COVID. In other words, you had COVID, but you're asymptomatic, right? You either didn't even know you were ill because you weren't, right? And it seems from what I've read that that could be quite high. In other words, some of you already might have had COVID, never knew you had COVID, and probably won't even know right now that you've got COVID. And these 32 million are confirmed. So they were tested by their doctor or a nurse or a swab test. So that number could well be, and probably is, a bit higher. But based on what we got, there's a 9%, 10% chance that you're going to catch COVID, right? So 1 in 10 Americans are probably going to catch COVID, give or take a little. That's our first probability. Does that seem less than you think when you read things and you hear about things, or does about 10% feel about right? What's your gut feeling? Do you think COVID feels like it's more prevalent, like more people have caught it, or does that seem more than that or less?
I feel like 10% is a high. Like,
so you would think your gut feeling is that I don't know. Well, if I took all the people I know, I don't think 10% of them have had COVID. Is that the kind of way you're thinking?
yes, yeah.
Yeah, that's true for me. And not that I have a big group of people that I know, but none of my family have caught COVID. and none of my wife's family have caught COVID. And if anybody was going to get it, would probably be me, because I don't like being in the house, so I go to the casino all the time. I do what they tell me. I wear masks and do my thing, but I probably would be one of the ones that would be more likely to catch it. I know some professors who hardly have left their house in the last year, which is a terrible lifestyle. So, 10%. What's the probability that you die of COVID? Should be less. I mean, if everybody who caught it died, wouldn't the death rate be 9.7%, right? So you would expect it to be fewer people. Great. And the number that I have got here,
excuse me,
is
wouldn't death rate be a bit different?
Yes.
Because 9.7% still means 9.7% of those who got it die.
Yes. No, that 9.7% isn't that. That 9.7% is just 9.7% of Americans got COVID. That's all that means. That's not who died of COVID.
And then if the death, you said if the death rate was also 9.7, then everybody would die, right?
Everybody who
that would be
caught
the
it
population. That would be the population going down. If everybody who had COVID died, that would be 100% death rate from COVID.
Well, you got to watch death rate. It depends on what you count the bottom number. I'm going to show you two death rates. This is the first one. Probability of people who died is 500,000. It's actually 540,000, so it's 0.54. So in the big American population, the death rate is 0.0018, which is about 0.2%. In other words, 0.2% of Americans have died of COVID. 9.7% of Americans, total number of Americans have died, have caught COVID, and of all Americans, only 0.2% have died. Now, what's the probability that you die of COVID given that you've caught it? Now, that's why there's two death rates. Of the 32 million Americans who had COVID, 0.54 died, right? Obviously, you can only die of it if you caught it, right? So I'm using that one. And if we use that one, 0.54 divided by 32, the answer that you get now is 0.017, which is about 1.7%. So you have to be very precise in how you say this. So I'll try my best. Of those people who caught COVID, 1.7% of those people who caught COVID will die. Of all Americans, 0.2% will die of COVID. Now, how do they fit in your idea of danger of COVID? And even if you catch it, there's only a 1.7% of you who will actually die of it. Not, I want anybody to die of it. And if you take all of America, only 0.2% of us have died so far of COVID. Do they seem small or big? David, I put you on mute because I had background sound.
Those seem small compared to the 10% of us having it.
Right. So I guess the question that once you've got data like this is, can you do a risk analysis, which is basically how dangerous is COVID? Well, it kills people, that's for sure. It's killed over 500,000, so it's not the measles, right? It's not something that kids get and you can worry about it. But even within this data, there's a lot of hidden information that I haven't seen. And I know it exists because I've calculated it. Do you know the chances of dying of COVID if you've caught COVID and you're a normal, healthy 25-year-old guy is minuscule. It's not 1.7%. It's more 0.017%. In other words, very few 25-year-old normal healthy males die of COVID. Now, do 25-year-old males die of it? Sure. They have underlying health conditions, heart conditions, they're overweight, they have asthma, right? Anything to do with the chest, anything to do with the heart, bad news if you get COVID. You don't want it. Do you know the other extreme? Don't be 80 years old and get COVID, because it's not 1.7% anymore. It's much higher. So when people talk about the dangers of COVID, they blank one number in when it's much subtler than that. Much subtler. So how dangerous is COVID? Very dangerous. Do you want a comparison? Let's do the flu. There are a lot of people say, oh yeah, it's just a flu. You know, what's the big deal? In a bad year, 61,000 Americans die of the flu. In a good year, it's 22,000. If you do that as a population thing of America, whoops, the flu is almost negligible. 61,000 divided by 320, 1, 2, 3, 4, 5, 6, times 100. About 0.02% of Americans die each year on a bad year, and it's probably 0.0, it's not even 0.01, it's 0.06% in a good year. So COVID, right? 100 times more deadly than the flu, as far as death rate goes. So yeah, it is a dangerous thing. I guess the question is, how dangerous is it? You know, and that's a very much a judgment call. But it's interesting that if you look at it from probability, doesn't it give you a kind of picture that you might not have got by seeing just the raw data? Because I know if somebody says 500,000 people died of COVID, that's a scary number, isn't it? Is it less scary when you say 0.2% of Americans have died of it? Or 99.8% of us haven't died of it? I like this data. It's real world data. So I've taken it just a little bit further. Here's Washington State. And I'm going to calculate the same three numbers. So this is the American average. 9.7% of Americans have caught COVID. 0.2% of Americans have died of COVID. If you've got COVID, the chances that you've died is about 1.7%. Let's look at Washington State. The probability that you have caught COVID in Washington State is 0.4 of a million, and the population of Washington State, according to the census, is 7.4 million. So that's people with COVID, and the bottom number is Washington State. So that's 0.4 divided by 7.6, which makes us 5.3%, which compared to the national average, isn't Washington kind of pretty good? I mean, nothing's good, but comparatively speaking, aren't we better than the general middle of the road number? So that's a good thing. Let's look at the probability that you have died through COVID. For Washington State, 5,444 people have died. Good grief. I'm going to have to do it as a real number because I'd probably get my zeros wrong. So 5,448 divided by 760,000 times 100. So what have we got? About a third of the death rate of the national average. And I'm making this rule of half the contagion rate, right? We catch about half what Americans do, and we die about a third. Not bad, right? And what about this number? What's the probability that you die given that you've got COVID? Well, there are 5,448 people have died out of 400,000. And 5,448 divided by 400,000. And the answer comes out at about 0.1. Oops, an extra zero. Oops, I'm putting the zeros all in the wrong place. About 1.4%. Have you any idea, any explanation for why these two numbers are very close to each other, whereas these were quite in multiples different, and these are just a little bit different? Why would these be similar and these could be, and they are quite different? But why should these pretty much always be similar, you would think?
I'm having a hard time explaining it, but that's just always going to happen. Like if you're gonna
If you catch
have COVID,
COVID, the chances
yeah,
that you die are the same no matter where you catch it.
right.
That kind
The
of
other
thing.
ones vary. The other ones vary just because of, you know, Washington's a healthier state, better healthcare, you know, things like that.
Not as dense, you know. One of the main factors in getting COVID is tight proximity to other people. So don't be in New York, for instance. That's a bad place to have to live for COVID, right? Lots of apartments, lots of people, all very close to each other. Not good for COVID. Be in a big, wide open place with lots of trees, right, and fresh air, and probably Washington State, right? You'll probably be okay. Okay, one more state. I have a number of choices here, but I won't do all of them. Do you want Texas, New York, or Florida? Let's do another comparison. Texas, New York, or Florida? Which one do you want me to do as the last version?
Florida. Do Florida.
You want to do Florida? Okay. So before I even hit you with the data, do you think Florida is going to be comparable to Washington, the same kind of numbers? Do you think Florida is going to be safer or more dangerous?
They're going to be more dangerous, I feel like.
And you want to, why do you think that may be the case?
Because they have all the beaches open and everyone's like, I feel like all the young, I don't know.
Everyone's ancient there.
That's probably the one I would be thinking of. One of the biggest death rates is caused by age. Just don't be 80 when you catch COVID, right? Your immune system's not great, you know, as good as it could be. Well, let's find out. Where's my Florida numbers? Okay. The probability that you catch COVID if you lived in Florida is 2.2 million people in Florida have caught COVID, and the population of Florida is 21.5 million. So 2.2 divided by 21.5, and the answer I get is about 10.2%. Twice the rate of Washington State. Pretty much the national average, right? Pretty close to the national average, right? But you're right, worse than Washington State. The probability that you die of COVID for Florida, 34,696 deaths out of 21 million. I'm doing it as a full number because I probably screw up my decimal places otherwise. So 34,696 divided by 21,500,000. And that's that guy, times it by 100 to make everything a percentage. And the answer I get is 0.16%, which is worse than Washington, but pretty close to the national average. And the last one is, what's the probability then that you die given that you've got COVID? Well, there's 2.2 million with COVID, and 34,696 have died of it. And so here goes. 34,696 divided by 2,200,000 times 100. And the answer is about 1.6%. You notice that that number is pretty much going to be about the same no matter where you are. Florida, a lot more people catch COVID, and because a lot more people catch it, a lot more people die of it. Washington, less so. I haven't got time for it. Do you know which state was the worst? Because I've done a few other states. The choices are Texas or New York. That's the only other two that I did. Which is the worst out of all of those?
Texas.
No,
Isn't it New York though?
surprisingly.
It was New York.
Yes, it was. It was New York.
Well, they also like they had the really bad at the beginning. It was really bad there too.
That was true. And it probably wasn't a good idea to send the COVID people who were old into nursing homes with other old people. That was probably a bad move, because old people are the ones that die. It would have been okay if it was young people and they didn't die. You could send them back, you know, to college dorms or whatever you would do. I don't know. Yeah, New York, worst one. But that number there, pretty much the same for everyone, including New York. So we lucked out as a national average of being in a really good state, at least half as dangerous as the national average. And we did that without knowing it. Oh, I forgot to tell you, there was one more. When you like to know what the world looks like. So let me bring back the United States. That number, that number, that number. I couldn't get really good data on the size of the world population. So the only one I can tell you is the probability that you die given that you've got COVID, because I could find those numbers and I was pretty happy about those ones. And the answer is 2%. So pretty much universally, no matter where you catch COVID, you've got somewhere around about what, 1.72% chance of dying of it. And that's a world figure. Now I could probably calculate these if I could get decent numbers. I don't know quite what the population is. And here is a data collecting problem. All these numbers I've got are as accurate as I can tell you, but there are lots of problems with some of them and none with others. The number that tells me people who died of COVID, I'm pretty sure that's good data. Because when people die and they had COVID, it's pretty obvious you died of COVID, right? You would assume that that would be obvious. I'm unsure of the number that I've been using for the confirmed COVID. Do you know, we talked earlier about asymptomatic, right? And there's good data on that. There's a lot of people who they believe have caught COVID, never knew they had it. And they may have gave it to other people and they died of it, but they didn't know they had it. So it's not really, they're not to blame, right? How can you be blamed for something you didn't even know you had? But that's a very unsure number. I don't know. All I know is it has to be more than the confirmed case, right? And it might be just 2% more, but it couldn't be 20% more. It could be quite significant. And that's a dangerous number. The population, that's good data. Right. I think we know how many people in America, I'm hoping, roughly. Good data. There's only one piece of the die with COVID that I would add to it. And I didn't like this when I looked at it because I was thinking, nah. Some states define dying with COVID differently than other states. Now you might say, why do you mean? In some states, if the reason you're dead is that the COVID kills you, then you are registered as death due to COVID, right? In other states, if you had COVID and you died, you are also registered as a COVID death. Now you might say, well, isn't that the same thing? No, I'll give you an example. Somebody who's terminally ill with cancer and has got 2 weeks or 2 months to live, they're going to die, right? They're terminally ill. If they catch COVID, did the COVID really kill them, or were they going to die anyway? Do you see why counting them or not counting them can influence your idea of death through COVID? And the fact that some places measure using one rule stick and different states use a different rule stick. Let's be silly about it. A guy's in a car accident and he gets killed. And when they take him and they do the autopsy, they discover he had COVID. Did the COVID kill him? No, the car accident killed him. Should that person be counted as a COVID death? In some states he would be, in other states he wouldn't. I don't like that. That clutters up the data. But it's a fascinating thing. If I ever get time, you know, maybe I'll take a sabbatical sometime and I'll do nothing but just look into the data with COVID, because it's been a pain in my life for ages. So I want to get my own back by finding out as much as I can statistically about it. And if I end up finding out that all that hassle and me not being able to visit my family in Scotland was totally unnecessary, I'm going to be pissed off. So I doubt it, but who knows? Okay, what we're going to show you now is back to our usual kind of stuff. Are you looking at homework chapter 7? Yay. Okay, so let's just do a look through some probabilities and show you similar kind of things. I'm pretty sure I remember doing this question. We did this one? Okay. Probabilities have to be between 0 and 1 or 0 and 100%. So you can't get negatives. So that's why you pick that one. And you can't get bigger than 1. So that's why you said no to that one, right? If you wanted to find the probability of something, just like I've been doing today, suppose you live in a city and it has 122,000 people and 950 of them contact for a survey. What's the probability that that was one of the people? Don't you just take 950 and divide it by that number, just like I was doing with the COVID. And you either turn it into a decimal or a fraction or a percentage, depending on what WebAssign says. In this case, it'd be a ridiculous fraction. I wouldn't have chosen fraction. Would you agree percentage or decimal would be just more sensible for that number? It's okay when it's 12 out of 20. And yeah, fraction works great, great with 12 out of 20, but not weird numbers. Right, we did the dice. I don't know, I'm trying to recollect, did we do any questions with sample space? I know I've done it. The reason I'm saying this is I've got two different classes, and during my break, I've managed to merge what I taught one into what I taught the other. Have we talked about sample spaces and getting data from tables? Did we cover that? Does anybody know what a sample space is? Did I talk about it? Okay, so we know we've covered that. Did I do any questions from tables? Don't recollect it? Right, that's a place where I'll start then. And if I haven't, the fact that we can't remember it probably means I should do some more, right? Just so that we do remember it next time. So I'm going to set up a kind of fictitious. Are we good? I'm going to set up a fictitious table with data, and we'll show you how you can get probabilities from this data. In particular, what are called conditional probabilities. A conditional probability this is an example of it. What's the probability that you die given your COVID? So a conditional probability is that you don't necessarily use all the data, you use subgroups of the data. So let's suppose that we have self-identified males, self-identified females, and what should we pick? I need something to ask. My brain's totally blank. I need something that's got a yes, no to it. I'm keeping this table simple that I could ask people.
Do you have pets?
That'll do. So the answer is going to be yes or no. So now I have to collect the data. So that's going to take me hopefully not too long, and I'm going to use you a lot to do that, if you don't mind. I have to stop the share so I can see the big screen. Right. This is only for the guys right now. How many of you have pets? One. You can do that little, probably easier actually for me to count if you do it this way. You see the little reaction thing and you do thumbs up? Right. How many got pets? 1, 2, 3, 4, 5, 6. Okay, well, let that drift away. Megan, you don't vote yet. You're voting too early. She can't take her anywhere. Okay. How many guys don't have pets? Okay, so I don't screw up my questions. I'm pretending that somebody here doesn't have a pet and he's a guy. I don't want 0. 0 kind of clutters up my data. Okay, you can vote now, May. How many have the female self-identified females have a pet? 1, 2, 3, 4, 5, 6, 7. How many do not have a pet? 1, 2, 4. Okay. So we are going to use this data that I've just collected, and we're going to use it to find some probabilities. And then we're going to see if I can analyze it. So here's my question. Let's phrase it differently. Is there any difference between the sexes and owning pets? So you could say, do females own pets more or less than males? Right, that kind of question. It's all contained in here. We just need to use it to collect things. And very often when you do these tables, you add a few more numbers, essentially totals. So there's a total of 13 and 5, and 7 and 11. Of course, they both add up to 18. So what's the probability that a male, if I just chose one person at random, that it's a male who had a pet? Well, there are 6 males out of 18 people. And if I use that, that comes out as 33.3%. Now, what's the probability that I choose somebody at random and it's a female who has a pet? Well, when I look at the females, there are 7 of you, and that's out of 18, and that's not going to be that different. So that's 7 divided by 18, and it's about roughly 39%, right? Do you think those two probabilities mean that females of pets are more likely to have a pet than a male? Do you think these are the numbers that I could use to argue that? Well, let me phrase it a different way. Why is it not a good idea to use those numbers?
Some
Sample
of us didn't
size?
vote, I think.
Well, that's true, but out of the 18 who did vote,
I feel like the sample size is way too small.
also true. Aren't there a lot more females than males? And if I want to do this fairly, shouldn't it be, equally balanced? So if there was twice as many females as there was males, but we all owned cats 50% of the time, wouldn't the data come out with more females out of the total than more males? You see, it would be it would be proportional to the number of people in each subgroup. So what we're going to do is a conditional probability. What's the probability that you own a pet, given that you're a male? That vertical line is the condition, right? So I know that it's a male, so that means there's 7 of them, and 6 own a pet. And so 6 divided by 7, the answer is about 86% of you. And then if I said, what's the probability that you own a pet, given that you're a female? And the answer is, yeah, there are more female pet owners, 7, but there are more females, 11. And when you do it as a percentage, we got about 64%. Now, those two, the conditional probabilities, are a much fairer way of comparing two groups, right? In this case, males and females, where there's a disproportionate amount of one or the other, right? There's more females than males in this case. Let me tell you how people using this set of numbers instead of these set of numbers, politicians in particular, can use that to give a very convincing argument that is totally false. So, you did not know this, but do you know Seattle is racist? Yeah. They don't hire enough Scottish policemen. Right? They hate Scottish people. They hate Celtic race. I'm a member of the Celtic race. They hate us. They don't like us. They're racist. And how do I know that? Because I collected data, pretend data, by the way, then 2% of Seattle are Scots. Only 2% of Seattle is Scottish people, right? Scottish ancestry. They do not like Scottish people, right? There's my evidence. What's wrong with that? I mean, it's actually false.
Well,
I mean, if that was real data,
if
it'd
it
still
was
be
real,
wrong.
you can't just like force Scottish people to like move there. Maybe they're not moving there because they want to live somewhere else.
When you do a percentage like that, shouldn't you compare it against the total population of Seattle? Right, so here's some more pretend data. Do you know that 2% of Seattle are Scottish and 98%, unfortunately, are not Scottish? If that was the real distribution of Seattle, isn't 2% of them being Scots exactly balanced and what it should have been? Seattle is not racist. The data doesn't show it anymore. These are conditional. And in fact, you would do, if you did the numbers, you'd actually find percentage of policemen who are Scottish over the total number of Scottish people, and it would be 2%. Imagine a different Seattle. 1% of Seattle is Scottish. Okay, that makes 99% or not. In that world, isn't 2% of Seattle being Scottish actually the opposite of being anti-Scottish? Aren't there twice as many Scots policemen as there should be according to the population size? So they actually like, I believe historically, weren't Boston policemen, weren't a lot of them Irish? Maybe more Irish than there were people in Boston who were Irish. Right? Oh, of course, on the other side of the coin, if 10% of Seattle was Scottish, wouldn't that number now be evidence that there definitely is some lack of representation, right? Some kind of racist thing going on, or at least they don't like Scottish or Celtic people. But when you see a politician doing their thing, do they even mention these? Don't they just hit you with that? If they tell you anything, or won't they just say that, you know, Seattle police don't like Scottish people? So when you look at data, when you are told something is true, try and look at it as a big picture. Think of conditional probabilities. Is that number they're giving me the right number? Is it telling me the truth, or is it distorting my reality? Remember the pets? Was it the reality, at least in my data, that males have more pets than females? 86% of males, have, at least the ones who identified as males, had pets, and only 64% of females. Whereas if we used this data, wouldn't we be arguing the opposite of that truth? And I think we've reached a really cool finishing point.